Okay, so the last example in the binomial handout, the partial fractions handout is linking it with the binomial expansion. So we have a fraction here, and it's asking us to find the first two terms in that expansion. However, we can't use binomial yet because there's two things in the bottom. So in order to do that, we have to use partial fractions to get two separate fractions and then do binomial on each one separately. So if we do the normal method, so 12x plus 5 over 2x plus 1, 3x plus 1. So I can write that as a over 2x plus 1 plus b over 3x plus 1. And I know I can do that because it's not an improper fraction, so it's fine to do that. Then I'm going to times both sides by 2x plus 1, 3x plus 1. So we get 12x plus 5 equals a. 2x plus 1 cancels out, so 3x plus 1. And b, the 3x plus 1s cancel out, so I get 2x plus 1. Choose your magic numbers. So for 2x plus 1 to be 0, I need x to be minus a half. So if I sub minus a half into here, I get minus 6 plus 5 is minus 1. Minus a half into here gives me minus 1.5 plus 1 is minus a half. So minus a half there, and minus half into here turns into 0. So therefore, A is the minuses cancel out, times it by 2, so A is 2. Choose the next magic number, so A is minus a third. So minus a third into there gives me minus 4, plus 5 gives me 1. Minus a third into there gives me 0. Minus a third into there gives me minus 2/3, plus 1 gives me 1/3. So third B, therefore B is 3. So 12x plus 5 over 2x plus 1, 3x plus 1 is, well, A was 2, so 2 over 2x plus 1, plus B was 3, so 3 over 3x plus 1. Okay, then we're going to use the binomial, so I'm going to rewrite it as 2 lots of, I'm going to rewrite this bit as 1 plus 2x minus 1 plus 3 lots of 1 plus 3x to the minus 1. Use binomial. So the first term is 1 plus n times x, and it only wants the first two terms, so that should be enough. Plus 3, then binomial on this one, so 1 plus n times x. Then expand it. Sorry, simplify the inside first to 1 minus 2x plus 3 lots of 1 minus 3x. Expand it. 2 minus 4x plus 3 minus 9x, which gives me 5 minus 13x. Okay, then part B says state the range of values for which this expansion converges. So that just means use that bit from the formula booklet that says the magnitude of x is less than 1. So from this first bracket, it was the magnitude of 2x is less than 1. So therefore, magnitude of x is less than half. And the second bracket was magnitude of 3x is less than 1. So magnitude of x is less than the third. And in order for them both to work, I need to choose the smallest. So that's the one where it converges. Good. Okay, just to show you the power of this, I've typed into my graph my original function, and I've also typed in green for some reason. I missed out the second one as my approximation. So 5 take away 13x, and I'm going to draw it, and I'm going to change my v window to the numbers I just said. So minus a third to a third. And let's look at, hopefully, you should be able to see that the blue and the green are quite close by. However, if I zoom out, they're going to start getting further away from each other, and the green's going to look nothing like the blue. So it's only like the blue between minus a third and a third. Now, if I keep zooming in, you should see that there's a region where they're pretty much identical.